Hi everyone. Today we'll be discussing the LeetCode problem of the day, maximum number of distinct elements after operations. Here you are given an integer array nums and an integer k. You are allowed to perform the following operations on each element at most once. So you have to pick, you can pick any element and add an integer from the range minus k to plus k to that element. And you just have to return the maximum possible number of distinct elements in the nums after performing the operations. So you can pick any element and you can choose to perform the operation. So you can either perform the operation or you can just leave the element as it is. So let's take an example. In this we have 1, 2, 2, 3, 3, 4. So initially in this array we have 4 distinct elements, 1, 2, 3, and 4. So we can perform few operations. Here the k value is 2. So this one we can add a -2 and make it -1. And for this 2 we can add a -2 to make it 0. And for this 2 we can add -1 to make it 1. So since k equal to 2, we can add any of these numbers from -2 to +2 to our numbers. So 2 becomes 1, and this 3 we can add a -1 to make it 2, and this 3 we can leave it as it is, and 4 also we can leave it as it is. So this is the final array, and in this we can see that 1, 2, 3, 4, 5, 6. We have 6 distinct elements, so our output will be 6. And for the second input we have 4, 4, 4, 4, and k value is 1. So the first 4 we can make it to 3, and the second 4 we can make it to 3, but it will be duplicate, so we leave it as it is. And the third 4 we can add a +1 to make it 5. For the last 4, like no matter what we do, it will collide with any of these numbers, so we can't do anything, so we just leave it as it is. So this is the resulting array. So in this, total distinct elements is 3. That is 3, 4, and 5. The output is 3. And the constraints are and the array size is up to 10 power 5, and each element can be up to 10 power 9, and also the k can be up to 10 power 9. Now let's go over the approach. So first let's start by sorting the array. So we'll process the elements from ascending order, and let's say the array is 4, 5, 7, 8, and the value of k is 3. So for the first number, we have a choice to reduce it or increase it. So since we are starting from the lowest numbers, let's try to reduce it to the least number possible. So 4 can be reduced to the least number possible, which is 1, by subtracting -3. So suppose if we don't reduce it to the least number possible, we only reduce it by 1, making it 3. So this might cause for collisions for the further numbers. So let's see how that happens. So for the 5, we have the range from since k equal to 3, 5 can go up to 8, and 5 can go up to 2. So this 5 can be transformed to any number from 2 to 8. But if we see this 4, we have just transformed it to 3, and this 3 lies in this range 2 to 8. So there can be a collision. So what if for this 4, instead of making it to 3, we reduce it to the least number possible, which is 1. 4 minus 3, 1. So now we can see that 1 doesn't lie in this range. So no matter what you change the 5 to, it will not collide with 4, with this number 1. So we have established one more thing, that it is always better to reduce the number to as least as possible to get to prevent the collisions in further operations. So let's just see the approach with an example. So let me take this example. And for this, let's say k equal to 3. Let's say k equal to 2. So first we have 3. We'll just transform it to the least value possible, which is 1. And then next we have 5. So we can see that 5 can be transformed from the range 3 to 7. So after transforming the first number, we have the previous value is 1. So the next available slot is 2, because you can't go beyond this number, because this is the we are going it in the ascending order. So our previous number is 1, and to avoid a collision, our next possible choice is 2. So our next possible slot is 2. So if you see the next number, it can be in the range 3 to 7. And our next slot here is 2. So no matter what you do, you can't reach 2. So what you do is you simply make it as the least number possible. So this 5 will be transformed to 3. After doing this, 3 is now our previous number, and the next available slot will be 4. So next free slot is 4. So again, next number is 5, and 5 has a range 3 to 7. But in this range, our free slot is lying in the range. So we can just make this 5 equal to 4. So this 5 will be 4. And since we have the previous number 4, our next free slot will be 5. So again, our next number is 5, and 5 can be in the range 3 to 7. 5 can be made in the range 3 to 7. So we can just make leave 5 as it is. So it becomes 5. And after this, our next free slot will be 6. So 5 is done. Now next our number is 6. So for 6, we have a range from 8 to 4. And since our free slot is lying in this range, so it is possible to make this number equal to the free slot. And after this, our free slot becomes 7. And for 7, 7 is in the free slot. It's in the range 4 to 8. So 6 can be transformed to 7. After this, our free slot becomes 8. And again, our number is 6. So this free slot lies in the range 4 to 8. So we can transform this 6 to 8. So 6 becomes 8. So we can get 6 to 8 by adding a 2. And now our free slot will become 9. Now if you see, our number is 6, and 6 range is from 4 to 8, but our free slot is 9. So no matter what you do to 6, you can't reach 9. So it will always be a duplicate. So for that, you can just leave 6 as it is. So 6 will be 6 only. So we can just put it here. Again, for this 6 as well, you can't reach 9. So let's just add it here only. And our next number is 13. So for 13, we have our range from 15 to 11. So our free slot is 9, but our range is from 11 to 15. So free slot is less than this range. So we can just assign the least value for this 13. So 13 becomes 11. So this is our resulting array after transforming. So in this, we can see we have 1, 2, 3, 4, 5, 6, 7, 8. So we have total 8 distinct elements. So the main approach is, first we'll calculate the previous value for the first number, and we'll get the free slot by just adding previous plus 1. And for the next number, we'll just see where this free slot fits in the range. So if the free slot is lying in this range, we'll just assign the previous number to be this number. Or if the free slot is less than this range, suppose in this case free slot is 9 and 9 is less than our range, so in that case we'll just set the answer to be the least of this range, and then we'll proceed. And if not, if the free slot is greater than this range, then we can't do anything, so it will always be a duplicate. So in that case we won't increase our answer, and just we'll move forward. It'll be a bit more clear if when we go through the code, so let's see that later. Now let's quickly code the approach. So first step is to sort the array, and let me take answer equal to 0 and also int previous value. We can just start by taking the previous value equal to nums of 0 minus k, and we can start with answer 1, and while iterating the loop we can just start it from index 1. I equal to 1, I plus plus. So the first index is contributing to a distinct value, so answer is 1, and the previous number is nums of 0 minus k. So we transformed the first index value to after by subtracting it with k. Now after this we'll just calculate our free slot. So free will be previous plus 1. Now we just have to see where this free lies in the range of the num. So if our free is less than, okay, if we have nums of I as our number, so the range is from nums of I minus k to nums of I plus k. We move this. Yeah, for any number our range is from nums of I minus k to nums of I plus k. So if our free is less than this range, that means free is less than nums of I minus k. So if it's less than this, then we can directly assign previous equal to nums of I minus k, and then increase answer. Else if our free is lying in this range, so that means free is less than equal to nums of I plus k. So this else if condition denotes this free is lying in this range. So in that case our previous will become free, and then answer plus plus. And in the else case, that means free is lying beyond this range, so we can't reach that number, so it will always be a duplicate. In that case we don't need to add answer or anything, so we just ignore that, and at the end just return answer. Okay, let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. For the time complexity, we are first sorting the array, so this is NlogN, and after that we're just iterating the array once, so this is the order of n. So the total complexity will be NlogN, and for space complexity it's constant, so we'll just have order of 1 since we are not creating any arrays or such, just answer variable and previous free and the iterator. I also have the code in Python if anyone wants to view it. I'll add it in the description as well, and let's catch up in the next video.